Yeah, let's get into that a little bit because, I go back to the earliest days for myself really in technology and being almost 40 years old kind of goes back to really the 90s when I first got my, very first personal computer, and it was like dial-up internet. I remember going to Kmart, of all places, to go get like the blue light special internet that dialed into the phone line in the house. And when that was on, no one could call, and
Yeah.
technology was almost this, at the time it seemed revolutionary, and looking back it truly was. But it was in its infancy compared to where it is now, and the growth has been exponential. So in terms of like deep learning and artificial intelligence, I mean, where did that really start? Where did we start getting this, internet connectivity from the world to this like machined learning? Was that even prior to what I'm thinking of?
Yeah, so the idea of artificial intelligence has been around for quite some time. So really in the 1950s, there were concerted efforts to move forward with, building a human-like intelligence. However, there were a lot of people at the time that thought it was going to be easy to do, and it'd just be 5 years from now. By
Yeah.
1960, that we'll have this worked out. And of course, that was not the case. And you alluded to something with that question, and that is the idea of exponential technology. So the idea
Right.
that things are getting better at an exponential rate. So there's something called Moore's Law, which I'm sure a lot of your listeners are familiar with, where technology gets basically doubles in speed every 2 years, approximately. And you run that for 40 years, well, that has a big effect, right? And so that's what we're seeing the result of. So a lot of what we see is kind of intelligence in computers is just the fact that they're just so darn fast,
Mm.
right? You could have done voice processing on computers in the past, but you really didn't want to wait 3 days for Siri to respond, as to your next turn on your GPS. That really wouldn't have been that helpful. But a lot of it just has to do with that increase in speed. But
Okay.
you're exactly right that there has been a real revolution in the last 10 years, this idea around machine learning. And so there's been several major advances to how these machine learning algorithms do learn, the neural networks that they use, and the feedback patterns through those um, networks. We sometimes call it back propagation, where data gets kind of fed back and these systems get better and better. And so that has been a real revolution. So you kind of combine both a technique, a process of doing things, along with really fast computers and processing power and memory. And well, you can have a lot of magic happen, right?
Yeah. It's funny because I have like I've tried to articulate a methodology in terms of, I guess it's kind of like just growing, right? In terms of like maybe optimizing someone's business, optimizing someone's sales technique. And the very last aspect or last pillar that I've articulated in this growth methodology is evaluate and adapt. And at the very core of what I think of artificial intelligence is that there is a super fast, intelligent computer that just evaluates and adapts faster than the human ever could consider or be capable of doing. I mean, is that something where it's like that's truly the core of AI? Is this, or at least even deep learning, is it's taking information or data that's being input, analyzing, and spitting out kind of new formulas to create these algorithms or whatever it is that we're programming it to do?
Um, well, let's just define AI.
Yeah, that's a good
So
idea.
AI is a really broad term, and it encompasses a lot of different things. I sometimes tell my students it's any machine that is capable of making a decision based on current data.
Mm,
Now, that could be as simple as your Roomba.
yeah.
Oh, I've hit a wall. I think I'll turn. Oh, I can hit the wall again. I'm going to turn. Okay, so that exhibits decision making behavior. It can be all the way from that, all the way to up to what we see in the movies, right? Some Terminator, if you want to go dystopian, or I think that most of them are kind of dystopian. Now that I think
Most of
about
them,
it,
yeah.
there's not a lot of good AIs out there in some ways, in the movies at least. But that's the general AIs at one end of that spectrum. But when we're talking about machine learning, a good example is from medicine. So in radiology,
Mhm.
pathology, cardiology, those doctors are in many ways technical professionals at recognizing patterns. So
Mm.
they're able to look at an x-ray and they're able to judge, does Scott have pneumonia or not? Well, what we can do is we can offload a lot of that technical decision making and pattern recognition to a computer. And so we can feed it 70,000 images of people that have pneumonia, 70,000 images of people that don't have pneumonia, and then we'll also feed it some images of false positives and false negatives. So we have a lot of variety in our data set. And then when I walk into the emergency room, or you walk into the emergency room and they take an image of us, they can run it through that algorithm and it will be much faster and more accurate. Now, they can't take that algorithm and then have it tell me what's wrong with my feet, right?
Right. Right.
So the problem is it's very narrow. It's a great use case. And as long as you're using that AI, using that machine learning algorithm for the use in which it was trained.